namely completeness. Now, completeness, I will talk about completeness in two contexts. First one I will talk about is completeness of the basis. We always say complete orthonormal basis. So how do we define completeness of the basis? Okay. So I am following this particular discussion is from J.D. Johnson, classical algebra. Let u n of x n is equal to 1 to n be a set of orthonormal polynomials. Consider a set of n orthonormal polynomials. When I say orthonormal polynomials, I mean un of x, m of x, the inner product is delta m. And let me define this inner product as integral minus infinity to infinity un star of x into um of x dx. Let's not worry about any weight, or even if some weight is there, I will absorb this square root of that weight with another square root of that weight with Let me consider this as an orthogonal set of polynomials. Now, any arbitrary function f of x can be written, can be approximated as f of x is approximately equal to sum over n is equal to 0 to infinity, okay, sorry, 0 to so let's say n is equal to 0 to n, okay, 0 to capital N, some Cn into un of x. This is not equal, remember, this is approximated. So if we have an orthogonal polynomials, we assume that any arbitrary f of x has such an expansion. And then, when I say it is approximately equal, I can always say there is an error function, not error function, there is an error. Error function is a very specified function in mathematics. So there is an error which can be written as f of x minus sum over n is equal to 0 to n Cn into un. This is the error in this approximation, in this approximate writing of this function in terms of the orthogonal functions. Now we ask the question, very generally asked all the time in physics, what is the best choice of the Cn such that the C of x is minimum? what is the best choice of the Cn such that E of x is minimum. So we ask this question, what are Cn such that E of x is minimum? But this question is a little bit vague because E of x is minimum means at what value of x? Because E of x is different at different values of x, right? So when I say E of x is minimum, you cannot answer this question in a general way. That is like any higher dimensional vector, you cannot compare them. You can only compare them by defining a particular norm of the particular norm you should define before you order, right? So in that way, we cannot ask this question. This is a bit vague, but we can ask the following question. So you can minimize what is called E of x mod square, the norm of E of x square, which is equal to integral minus infinity to infinity E star of x into E of x dx. So minimize this quantity. You can ask a question, you minimize this quantity. So how do I do this minimization? You know what is E of x, that is written here.